Hey everybody, welcome to our meteorology segment. This was originally streamed live to Twitch at twitch.tv/smAsho. Make sure you go follow us over there to know when we go live. We do stream live on YouTube as well, thanks to our BitChute subscribers. Let's do it. Here are the jet streams of the Western world. We're seeing extreme meridional jet stream flow once again, folks. Normally the jet stream just kind of flows like this, but sometimes we see this meridional jet stream flow like we see here, where it's traveling parallel to the prime meridian. In other words, in a north and south fashion, as opposed to a normal west to east jet stream. Great example of that here over the North Atlantic. Multiple 180-degree bends showing up there in the jet stream. Here are the surface winds of the western portion of planet Earth. Some powerful winds here south of Iceland. Let's take a look at the eastern portion of the planet. There you go. Shout out to our viewers from Hawaii and from the rest of this side of the planet. Some strong winds here south of the Aleutian Islands, as well as south of Australia. Here are the jet streams of the east. An extreme bend here. Got the jet stream blowing one direction over Western Australia there, and then the other direction only maybe 50 miles away. So some pretty violent jet stream motion there. Let's continue on. And check it out, folks. It's so hot that it's cold. That's a thing now, by the way. It's so hot that it's cold. Were you aware of this? Check out the weather.gov map, folks. Check out the weather.gov map. You see all those purple areas? Those are all freeze warnings. Freeze warnings. It's still summertime. These are frost advisories, all these blue areas. Frost advisories and freeze warnings. Also, 5 winters in a row with record snowfall in the northern hemisphere are obviously an indication that the planet is so hot that it's cold. Obviously, thermodynamics works in such a way that when you get a really hot planet, it gets cold because reasons. We've got some strong lightning here over the central U.S., a band going all the way from Arkansas to Lake Michigan. Quite a significant band of lightning there. An indication that there's some cold air dropping in, creating massive pressure gradients. Let's take a look at the real-time lightning map next at lightningmaps.org. Lightningmaps.org, powered by blitzertung.org. German is the best language to yell at people in. Hey, St. Louis, there's thunder rolling in. Yowzers. Pretty active series of cells there right near St. Louis. Shout out to our viewers from the Midwest. Also some cells near Springfield and Joplin and Fort Smith. I like to use lightningmaps.org when I hear thunder. Check it out. You can convince convince your friends and foes that you're Thor and that you're causing the thunder. Anyway. Next, look at a pressure cells here. And let me just check the life of the stream. We are streaming live, folks, just so you know. Streaming live here at the Smash News Network, least busted. Name it news. Anyway, here are pressure cells on windy.com. Let's advance this till tomorrow. There's where we expect pressure to be at 1 p.m. Eastern Daylight Time tomorrow. If you're wondering where we're located, it's in the Lehigh Valley, right about there. Lehigh Valley, Pennsylvania, just west of New Jersey. And again, that's the European forecast for pressure at 1 p.m. tomorrow. Next, your simple water vapor map here on the NexRad. Really, there's 2 different bands of moisture there. And let's take a look at the U.S. Doppler Radar. And shout out to our Alaskan viewers once again. Thanks for leaving comments. And here's a lower 48 radar animation. You can see those two bands of moisture both causing some precipitation, with a dry spot in between around Indianapolis. Although it's going to rain, Indianapolis. Here's what's going on in the cloud layer. It's the shortwave radiation map. And here's the water vapor map. That should give you the most insight. Let me speed that up to the same speed as the other map. There we go. We've got multiple interacting air masses here. I can see there's a double air mass going on at this moment right here. Anyway, let's just do a recap and close out this meteorology segment. Once again, there is the U.S. Doppler Radar. Here's the cloud layer, otherwise known as the shortwave radiation map. And there's the water vapor. What's driving this right now, folks, is this cold air being driven down from Canada. And it's creating some huge pressure gradients there. Hopefully that helped you out. If you're wondering what's going to happen next with the precipitation and so on. Thanks for tuning into our meteorology segment. I've been your host, Dan, a.k.a. smAsho, signing off from the Smash News Network, least busted. Naming news.